Note of first standard 11. Chapter is that name is a gravitation. We will cover it in details. Let's start from meaning of it. Every object, each object in the universe, not only in our world, in the universe, attracts every other object. One object attracted to other object, but each and every object in the universe attracts every other object with a force, and that force is called as force of gravitation. So that force which is being a object is being attracted by other object, so that force is known as a gravitation force. Means there are two objects and both are attracted to each other, so that force is being applied between them to bring near. So that force is known as a gravitation force. Okay, so this simple sentence is very famous, which is every object in the universe attracts every other object with a force. That force is known as gravitation force. Gravitation is one of the four classes of attraction found in nature. ये ग्रेविटेशन फोर्स है, ये वन ऑफ द फोर क्लासेस जो कि अट्रैक्शन फाउंड पाया गया इन नेचर. लेट्स से दोस फोर attraction. First we have the gravitational force which we are discussing. Second which is the electromagnetic force. It is taught in 12th standard. Right now we will not discuss about electromagnetic force in details, but little bit, not too much. And third we have a strong nuclear force, also called the hadronic forces. And fourth is the weak nuclear forces. These are interactions which was found in nature. We see gravitational force happens in nature, electromagnetic force happens in nature, the strong nuclear force happens in the nature, weak nuclear force. One question from me: what, which one is the most strong, most weakest force? So answer should be gravitational force, not weak nuclear force. Okay, so most strong, which is so answer would be the strong nuclear force. Although of negligible importance in the interaction of elementary particles, gravity is of primary importance in the interaction of objects. It is a gravity that holds the universe together. Yeah, whatever you see, uh, earth is or earth is rounding around a sun. It is happening because of gravity. Okay, gravity is holding holding the universe. Okay, this is force. Newton's law of gravitation. Newton's law of gravitation. Law of gravitation of Newton. Gravitational force is a attractive force. Yeah, we know. When it comes to electromagnetic force, we know that the coulombs attracts and repel. But when it comes to gravitational force, we see that only one force, attractive force. Both bodies cannot repel to each other, but attract to each other when it comes to gravitational force. Okay, and it is a very weakest force. This is the most weakest force. That's why we are not able to observe gravitational force between two objects around us. Gravitational force is the attractive force between two masses m1 and m2 separated by a distance. We see that there are two masses and there will be distance. So if you increase the distance, I will tell you later, but right now just understand. We will take two masses m1 and m2, and we will observe a distance between them. That's it, nothing else. And the gravitational constant. So the gravitational distance, we will represent distance by air and mass by m1 and m2. The gravitational force acting between two point objects is proportional to the product of their masses. Means force which is acting between two bodies, so that force will be directly proportional to product of a masses two masses product of their two masses, and this force will be inversely proportional to the square of distance between them. Try to understand. If we increase r, then what will happen? Force will decrease. Force which is acting between them will decrease automatically. If we increase distance, what if we decrease r, then what will happen? Then force will increase, which is acting between them. Okay, this will happen. It is the meaning of inversely proportional. Okay, so proportional means if force is increasing, so mass of the object will increase. I would not say mass, but if a mass of the body is more, then forces will be more. Okay, forces will be more. If a distance is less, if a distance is increasing, force will be decreasing. If a force is decreasing, it means r is increasing. Okay, this is meaning gravitational force. So equation which we get is F is equal to z m1 into m2 upon r square, where z is nothing but gravitational constant force. This is a universal gravitational force. Okay, gravitational, it's not a force but universal gravitational constant. Z is over here. This is a universal gravitational constant. Remember, this is a universal. So value is fixed. Okay, this is fixed. We can't change it at all. So the value of Z is considered as, this is nothing but 6.67 multiple 10 raised to power minus 11 Newton meter square kg minus 2, and is the same throughout this universe. If you go America, then you will use the same value of Z. Okay, if you go uh, uh, anywhere, this same value you will use. This is the meaning of universe. So this value will remain same throughout the universe. The value of a z is independent of the nature and size of the body as well as the nature of the medium between them. Remember, for gravitational force, this gravitational force don't care about a medium. If bodies are in water, gravitational force will be same. Okay, don't think that gravitation there will be effect of a gravitational force if a medium is changing. No, if medium is changing, gravitational force will not care about the medium. Value will come same. Value will come same. Dimension formula of Z is, we are talking about a gravitational universal gravitational constant. Okay, so dimension formula for it will be m raised to power minus 1, l raised to power 3, and t raised to power minus 2. Now let's see important points about a gravitational force, not a gravitational constant. Hmm, Gravitational force. So important points. First, we have gravitational force is the central. Here we take, for example, we are taking Earth and another object which is at the surface of the Earth. So remember, if you finding a distance, so you will have to start from the center of the Earth, and you will have to end up from the till the center of the other object which is at the surface of the Earth. Okay, so you will have to start from the center of the bodies of two bodies. This is known as a central force. So gravitational force is a central as well as a conservative force. This is also conservative force. because it does not care about path, actual path. Okay, actual path. Gravitational force don't care about actual path. It will take only straight line. Straight line. It can be a vertical or horizontal. Remember, it is a conservative force. Second, we have it is the weakest. It is the weakest force in the nature. Yeah, this is known as weakest force. Because even reason I would not say reason, but here in a real life we can see there are a lot of objects, but both are not attracting with too much force. But still both are attracting, but with a very less amount of a force. Okay, very less amount with a very less amount of a force. Third is it is a 1036 times smaller than electrostatic force, and 10-18 times smaller than nuclear force. This is very too much weak force. Sixth, not sixth, but fourth, the law of gravitational. The law of gravitational is applicable for all bodies, irrespective of their shape and position. Size, shape, and position. Fifth, we have gravitational force acting between sun and planet, provide it centripetal force for orbital force. We say that sun is moving around earth, or you can say earth is moving around the sun. It is happening. Why not? Why they are not falling? The reason is centripetal force. Centripetal force is making them circular motion. Okay, if any object which is moving circular, it means they are able to move circularly due to centripetal force. Gravitational pull of the earth is called gravity. Gravity is a special case of gravitation. This gravitational pull of the earth is called gravity. Seventh, we have Newton's third law of motion. Newton's third law of motion is action reaction pair of equal equal force. Action reaction pair. It means the gravitation forces between two bodies are action reaction pair. This is Newton's third law of motion. Now, following three points are important regarding the gravitational force. When you are talking about gravitational forces, so these three points will be important to follow. So, unlike the electrostatic force, we know if it is independent of the medium between the particles. Yeah, again, electrostatic force will not care about medium. It is a conservative in nature. Electrostatic force also this is also conservative, where gravitational force is also conservative in nature. Third, it expresses the force between two masses of an equal volume. However, for external point of spherical bodies, just understand that Newton's law of gravitation hold goods for object lying at you. This is enough about gravitation. About the gravitation. Now let's see acceleration due to gravity. Acceleration due to gravity. The uniform acceleration means acceleration is constant. produced in a freely falling object due to the gravitational pull of the earth is known as acceleration due to gravity. Means on the surface of the earth there is an object which is falling downward towards the center of the earth. So with uniform acceleration it is known as a acceleration due to gravity. Acceleration due to gravity at the surface acceleration or z will be 9.8 meter per second raised to power 2 at surface. It is denoted by g and its unit is a meter per second raised to power 2 and it is a vector quantity. Remember this is a gravity which is a special case of a gravitational acceleration due to gravity. So its unit is a meter per second raised to power 2 and it is a vector quantity and its direction is towards the center of the earth. We will take center of the earth. The volume of a z is independent of the mass of the object which is falling freely under gravity. The volume of z changes slightly from place to place. Yeah, if you put object at certain height from the surface of the earth, then what will happen? Z will change itself. The value of Z is taken to be 9.8 meter per second raised to power for all particle purpose. This is the exact value which is at the surface of the earth. The value of acceleration due to gravity on the moon is about 1/6 of that on the earth, and on the sun is about 27 times of that on the earth. So acceleration, the value of acceleration due to gravity, 27 times. Among the planets, the acceleration due to gravity is minimum. Relation between z and a is given by g is equal to zm upon r square, where m is the mass of the earth, which is 6.0 multiple 10 raised to power 24 kg, and r is the radius of the earth, which is equal to 6.38 multiple 10 raised to power 6 meter. If you put when you will put value of mass of the earth and value of radius of the earth, then you will get a g value of z, which will come out as a 9.8 meter per second raised to power. G is a universal gravitational constant. Acceleration due to gravity at height h above the surface of the earth is given as gh will be equal to gm. Just we will add h plus with the r. Everything will be same. Then it will be equal to g into 1 minus 2h upon r. This formula we will get. Factors affecting acceleration due to gravity. Factors affecting acceleration due to gravity. First of all, let's see shape of the earth. Acceleration due to gravity g and in free will be equal to 1 upon r square. Earth is elliptical. Over here, Earth is elliptical in shape and its diameter at poles is approximately 42 kilometer. This is a diameter 42 kilometer less than its diameter at equator. Therefore, G is a minimum at equator and maximum at poles. Second, rotation of Earth about its own axis. If W is the angular velocity of rotation of the Earth,